Hey guys, welcome to 5 Minute Classes, wherein today we'll be looking at integration by parts using Bernoulli's principle. So this is a pretty straightforward method, and according to me this is one of the easiest and fastest way to integrate given two functions. And there's no particular formula as such in this method. You just have to keep this rule in memory, which is the I-late rule, wherein I stands for inverse, L is a logarithmic function, A is arithmetic, T is trigonometric, and E is exponential function. Now I'll tell you why we require this as and when we proceed. Let me start off with the first example. Let's say I have to integrate x log x. Now we have two functions here, one is x, the other one is log x. So now we separate these two functions based on this rule, wherein we integrate or differentiate these two functions. So let me draw two columns, d and I. So now to decide what function I'll differentiate and which one I'll integrate, I'll use this rule. So if I consider x is an arithmetic function, so x is over here, it's the third in the rule. And when we take a look at log x, it's a logarithmic function which is second, which means L comes before A. So the function which comes before, which is the initial function, that will be differentiated. So I'll write log x here, and under integral, I'll write the other function x. Now we have to integrate or differentiate these two functions until a point wherein you are able to multiply the two answers and be able to integrate them. Let me show you how to do that. So let's differentiate log x. I get 1 by x, and when we integrate x, I get x square by 2. So now what we have to do is check whether these two when multiplied is integrable or not. 1 by x into x square by 2 will give me x by 2, which is integrable. So I'll stop at this stage. So now what I do is, once I stop at this stage, I multiply the diagonal elements, which is log x and x square by 2, with the positive sign, and the horizontal element with a negative sign. So basically this is alternate positive and negative. If I had further steps, I would multiply the next diagonal element, which I'll show in the next case. So now once I do this, I can write this as I. So I can express I as the product of these two terms, which is log x into x square by 2 with a positive sign, minus x square by 2 into 1 by x, minus because I'm multiplying these with the negative sign. And now this term which you have, which is the product of the horizontal terms, this should be under the integral. So now I can write this as log of x square by 2 minus integral x by 2, which is x square by 4. So this is your final answer. Of course, you can take x square by 2 and simplify it further, but I guess you get the idea. Now let's move on to the next example. Let's say I have to integrate e power x sine x. Now here, according to this rule, if I consider e power x, it's an exponential function, whereas sine x is a trigonometric function. So since t is before e, let me consider sine x to differentiate and e power x to integrate. So again, let me make the two columns d and I. So I'll consider sine x under differential and e power x under integral. Now when you have such functions, you have to consider that both the functions can be differentiated and integrated infinite number of times without getting a fixed value. For example, if I keep differentiating sine x, I'll get cos, sine, so that will keep going on. And when I keep integrating e power x, I'll have e power x itself. So what I do is, I come to a step wherein I'll be able to multiply the two and get back what is inside the integral. For example, now if I differentiate sine x, I get cos x. Whereas I integrate e power x, I get e power x again. Now we can't stop at this function because I'm not able to integrate the product of these two. So now let me go further. If I differentiate cos x, I get minus sine x. When I integrate e power x again, I get e power x. Now if you notice, if I multiply these two functions, I get exactly what's inside the integral. So I stop at this stage. Now I multiply the diagonal elements, this with the positive sign, this with a negative sign, and this two horizontal functions with the positive sign, since it's alternate positive and negative. Now if I denote this by I can write I as e power x into sine x with a positive sign, minus e power x into cos x, and plus minus sine x into e power x, which is minus sine x into e power x. But as you know, the final function should be under the integral. Now if you notice, this is the same as I, so I can write to I is equal to e power x sine x minus e power x cos x minus I. Now when I goes to the other side, I get I is equal to e power x sine x minus e power x cos x divided by 2. Basically it's 2i is equal to this, so I is equal to this answer. So this is the way you integrate when you have functions which can be differentiated / integrated indefinite number of times. So hopefully this example has given you a clear idea of what Bernoulli's principle is and how to go about integration by parts. If you have any suggestions or any feedback or doubts, you can please leave them in the comment section down below and I'll try answering them as soon as possible. Thank you so much for watching and please stay tuned for more.